Here, I will share some important tips for predicting the number of signals in H1 or 13C NMR spectra. First tip, count the number of non-equivalent hydrogen or carbon atoms. As you know, each non-equivalent hydrogen or carbon will give a separate signal in NMR spectrum. Therefore, number of signal is equal to number of non-equivalent hydrogen or carbon of a molecule. You also know each non-equivalent hydrogen or carbon will have different chemical shift as their electronic environment is different. For example, on a screen you are observing H1 NMR spectrum of 4-bromoacetophenone. As seen in the structure, there are three types of hydrogen. So three signals you are observing. Two are in aromatic region while methyl signal is appearing at 2.5 U delta as a singlet. Tip number 2. Look at the structure of the molecule. Find out molecule contains a chiral or stereocenter. Chirality introduces distereotopicity, causing atoms or ligand attached to molecule to become a non-equivalent. This leads to a separate signal for each distereotopic atoms or ligand, leading to a increasing number of signal. Consider the example appear in CSIR examination June 2015. Number of signal in the C13 NMR spectrum of are 4-methyl pentane 2-ol are 4 options were given. As absolute configuration is mentioned, given molecule is chiral. So let us draw the structure of molecule. C2 carbon is chiral, which makes the methyl attached to the C4 carbon distereotopic. Hence, both the methyls will give different signal in C13 NMR spectrum, giving total 6 different signal in NMR spectrum. Hence, correct option should be D. So, as chirality induces distereotopicity, number of signal may increase as chemical environment of each distereotopic atoms or groups is different. Tip number 3. Look at molecular symmetry as it plays a crucial role in analyzing NMR spectrum. Find out symmetry elements such as rotation axis, mirror plane, inversion center, and improper rotation axis. These operations make the atoms and groups equivalent, resulting in less number of signal and thus gives simplified spectrum. Let us consider the next example. In the broadband C13 NMR spectrum, number of signal appearing for the two pyrindiols A and B respectively are. Structures were given as well as 4 options were given. To find out the number of signal for this molecule, let us find out first symmetry elements present in a molecule. Look at the structure of pyrindiol A and B. Both molecule contains total 16 carbon, but due to the presence of C2 axis, number of signal will be less. In molecule B, one C2 axis is present, giving 10 different non-equivalent carbon, which gives the 10 signal in C13 NMR. Molecule A contains 2 C2 axes, giving 5 different non-equivalent carbons, which gives 5 signal in C13 NMR. Therefore, option C is correct. So please look at the symmetry elements present in a molecule and find out number of non-equivalent hydrogen and carbon. With this background, let us see the next example. Number of signal present in a proton decoupled C13 NMR spectrum of the following compound is. 4 options were given. Look at the structure of the molecule and find out symmetry element present in a molecule. Molecule contain 2 mirror planes, one vertical mirror plane and one horizontal mirror plane, which divide whole molecule into 2 equal halves. Even though it contains 16 carbon, there are only 4 non-equivalent carbon, giving 4 signal in C13 NMR spectrum. Hence, option A is correct. Apart from the chirality and molecular symmetry, there are 2 more factors which affect number of signal in NMR spectrum. We will discuss conformation and restricted rotation in the next video. Thanking you.